Good morning to everyone. In previous video we discussed about basics of inverters. That is, what is the concept of inverter, what are the applications of inverters, and what are the classifications of inverters and working of basic bridge type inverters. In this video we are going to discuss about concept of series inverter and working of series inverter. Coming to introduction of series inverter is nothing but the inverter in which the commutating elements are connected in series to the load. Here commutating elements are nothing but energy storage elements, that is inductor and capacitor. The inverters in which inductor and capacitor are connected in series to the load, those type of inverters are called series inverters. Okay, coming to working principle of series inverter, the working principle of series inverter is depends upon the class A commutation. That is, class A commutation is nothing but this is the one of the type of the forced commutation. Okay, the working of series inverter is depends upon this class A commutation. And similarly here the commutating elements and load forms the underdamped system. Underdamped system is nothing but in which the damping factor of the system is less than unity. That is nothing but underdamped system. This is the introduction of series inverter. That is, the commutating elements are connected in series to the load and it works on the class A commutation principle and it forms the underdamped system. Coming to circuit description of series inverter, it consisting of two ACRs, commutating elements, those are nothing but inductor and capacitor, and load. This entire thing is supplied by the DC voltage source. This is the circuit diagram of series inverter. In this we are using two thyristors, T1, T2 and commutating elements inductor and capacitor and load. Here these commutating elements are connected in series to the load and this entire circuit is supplied by the constant voltage source VDC. Here the working of series inverter depends upon the class A commutation. That is nothing but by using the voltage across this capacitor we are going to turn off the main thyristor T1. Then we are going to get the AC voltage. That's the working principle of class A commutation as well as series inverter. Now we are going to discuss about working of series inverter. Coming to working, the concept of working of series inverter is very simple. Listen carefully. That is, by applying the constant voltage source to the circuit, thyristor T1 is in forward blocking mode and thyristor T2 is in forward blocking mode. Without applying the gating pulses to these two thyristors, both the thyristors act as a open circuit. There is no path for current from source to load. Now at time t is equal to t0, we are going to apply the gating pulse to thyristor T1. By applying the gating pulse to thyristor T1 comes from forward blocking mode to forward conducting mode and it acts as a short circuit and it allows the flowing of current from source to load in the direction of VDC plus thyristor T1, capacitor, inductor, load and VDC minus, that is nothing but in this path. And here capacitor starts charging with upper plate as positive and lower plate as negative. Whenever this capacitor charges to the voltage VDC, that is nothing but whenever VC is equal to VDC, the potential difference between this capacitor and this voltage is 0. If potential difference is 0, there is no path for current from this point and this point. Means the current flowing through thyristor T1 becomes 0. Whenever current flowing through thyristor T1 becomes 0, the thyristor T1 comes to off state. That is nothing but class A commutation. That is, whenever VC is equal to VDC, the current flowing through thyristor T1 becomes 0. Why? Because the potential difference between VDC and capacitor C is 0. So the current flowing through thyristor T1 becomes 0. If current flowing through thyristor T1 becomes 0, thyristor T1 automatically comes into off state. In previous case, capacitor C is charges with upper plate as positive and lower plate as negative and it having the voltage VDC. Okay, whenever VC is equal to VDC, the current flowing through thyristor T1 is 0 and thyristor T1 comes into off state. Now in this case at time t is equal to T1 we are going to apply the gating pulse to thyristor T2. Due to the application of gating pulse to thyristor T2 comes from forward blocking mode to forward conducting mode and it acts as a short circuit. Due to the short circuit of thyristor T2, here capacitor starts discharging in the direction of C plus thyristor T2, load, inductor and C minus, that is nothing but in this direction. Here C is nothing but C plus and here C is nothing but C minus. After complete discharging of this capacitor, that is nothing but whenever Vc is equal to 0, capacitor changes its polarities, that is upper plate as negative and lower plate as positive, and the current flowing through thyristor T2 becomes 0. Whenever current flowing through thyristor T2 becomes 0 means thyristor T2 comes into off state. Here there is no path for current from source to load, that is nothing but the current flowing through thyristor T1 is 0. In previous case, after complete discharging of capacitor, capacitor changes its polarities, that is upper plate as negative and lower plate as positive, and thyristor T2 comes into off state. In this case, at time t is equal to T2, again we are going to apply the gating pulse to thyristor T1. By applying the gating pulse to thyristor T1 comes from forward blocking mode to forward conducting mode and it acts as a short circuit, and it allows the flowing of current from source to load in the direction of VDC plus thyristor T1, C, L, load and VDC minus, that is nothing but in this direction. Here VDC is VDC plus and VDC minus. In this case also capacitor starts charging up to the voltage VDC but in opposite direction due to the opposite polarities. Whenever this capacitor charges up to the voltage minus VDC, again thyristor T1 comes into off state. When thyristor T1 is in off state, the current flowing through thyristor T1 becomes 0. Again we are going to apply the gating pulse to thyristor T2. By applying the gating pulse to thyristor T2, again capacitor starts discharging. After complete discharging of capacitor C, again capacitor C changes its polarities. Again we are going to apply the gating pulse to thyristor T1. Same cycle going to repeats. By using this analysis, we are going to draw the waveforms. These are the waveforms depending upon the above analysis. Here Vn is the constant DC voltage source, Ig1 and Ig2 are the gating pulses which we are going to apply to the thyristors T1 and T2, and Vc is the voltage across capacitor and It1 is the current flowing through thyristor T1. Initially at time t is equal to T0, we are going to apply the gating pulse to thyristor T1. Due to the application of thyristor T1 comes from forward blocking mode to forward conducting mode and capacitor starts charging, means the voltage across capacitor is increases up to the voltage VDC. Whenever the voltage across capacitor reaches to the voltage VDC, the current flowing through thyristor T1 comes to 0. Whenever current flowing through thyristor T1 comes to 0, T1 comes into off state. Means in this duration the voltage across capacitor is plus VDC and thyristor T1 is in off state, means the current flowing through thyristor T1 is 0. Again at time t is equal to T1, we are going to apply the gating pulse to thyristor T2. Due to the application of gating pulse to thyristor T2, capacitor starts discharging, that is capacitor starts discharging from VDC plus to 0. In this duration also thyristor T1 is in off state, so the current flowing through thyristor T1 is 0. After complete discharging of thyristor, after complete discharging of capacitor, thyristor T2 comes into off state. Again at time t is equal to T2, we are going to apply the gating pulse to thyristor T1. Again due to the application of gating pulse to thyristor T1, capacitor starts charging in opposite direction, means the voltage across capacitor is increases in opposite direction. Whenever the capacitor voltage reached to the voltage minus VDC, the current flowing through thyristor T1 comes to 0, and same cycle repeats for the remaining intervals of time. These are the waveforms depending upon above analysis. Coming to practice problem which I have given in previous video, that is determining the value of inductor which is connected in series to the capacitor in the load of a inverter having the resonance frequency of 5 kHz. This is one of the gate bit for 1 mark depending upon the inverters. That is, the concept is very simple. We are having the resonance frequency and capacitance value. We have to determine the inductor value which is connected in series to the capacitor in the load of a inductor, in the load of a inverter. We know formula for resonance frequency in series resonance, that is resonance frequency is equal to 1 by 2 pi into root LC. In this we know resonance frequency value and capacitance value. Okay, from that find out the inductance value. Okay, by simplifying this one we are having the inductance value L is equal to 0.0002157 henries. This is the concept and working of basic series inverter. In the coming video, we are going to discuss about working of basic parallel inverter. Thank you.